Hello, chemistry. This is Mrs. Ellsworth. Okay, how would you report this calculation? Okay, when I go and I stick 37.40 times 104 in my calculator, I get this value. Now, how would you report that? So what I would like you to do is I'd like you to stop a moment and I'd like you to tell me how you would report it. So go ahead and circle one on your sheet and click pause. And we're going to come back to this several times. Okay, now there are some rules for rounding, and you'll notice that there are some crazy rules for rounding that you've never heard of before in math. And we're going to just stick with math. We're not going to bother with those bottom three. We're just going to know that if the number that you're rounding, okay, like let's say we have to go to the 10th on this one, that this number is greater than 5, so we're going to round up, and we're going to get 56.9. On this one, we're going to round to the 10th. Hey, this one is not as, it is less than 5, so this one we're not going to round up. We're just going to slice that 2 right off. And we're going to do that just like we've always done in math. Okay, so now we got this rounding thing. Again, how would we report this one? Well, to be able to answer this question correctly, we need to know something about significant figures. Now, significant figures I also call sig figs. We need to use significant figures to figure out, like in the case of this problem again, we need to figure out how many significant digits that there are in each one of these so that we can put the correct number of significant figures over here. So to do that, we need to know some rules. The first one is that any digit that is not a 0, the 37 and 0.4, the 1 and the 4, those ones are significant. So really the only ones that we have any trouble figuring out whether they are significant or not are the zeros. So the zeros are the confusing part, so we have other rules for them. Now if the 0 is a placekeeper, then they are not significant. So 250, this 0 right here is just a placekeeper. Now, it's saying that's not significant for when we report our values, but it is still important because it's not 25 here, it is 250. So we're talking about significance as in how many digits that you can report when you are showing your answers. Because all measurements, remember, have some estimation in that very last digit. Well, is it this digit that's estimated or is it this one? Well, it's the 5 because this one is not significant. Anyway, moving on, this one has never been significant. In fact, when you write out your answers in math or in science, you don't even print that 0. Now the next one, well, it is a placekeeper, and that means it is not significant. All these 6 zeros are not significant either. There's only one significant digit in 3 million. There's 2 in this 12 thousandths one. Now, zeros that are between non-zero digits are significant. So this one will be significant. So that means that there's 3 significant figures or 3 sig figs in this part, in this factor. Okay, and so, oh, I forgot to mention this. When we're talking about placekeepers, this one is not significant, but sometimes they've got an old rule that they do, that they show this little decimal here, and that kind of encloses everything with this decimal. When it's the very last one, you see a decimal next to it. That means that this guy is significant. This is a way of reporting 2 sig figs. This one is reporting 3 sig figs. Sorry, I forgot about that. Anyway, back to the non-zeros. When they're between them, then they are significant. So this value will have 4 significant figures, and same with this one. Now this bottom one that's showing precision, this 0 does show precision. So do these two, but this one does not. So sometimes I tell my students just to worry about number 5 more than you worry about number 4, because if the decimal, okay, the decimal, you got to look at that. We got to look at where all the non-zero digits are. If the 0 that you're questioning, okay, if this 0 is to the right of any decimal and also the right of any non-zero digits, it is significant. It's showing precision. Now this one is not to the right of some non-zero digits, so that one won't be significant. However, this right here is to the right. Both of these two are to the right of a digit, a non-zero digit, and to the right of the decimal. So that is showing that these two are significant. This one has got 3 significant figures. And this one, all of them are significant. And that's important when we need to do our calculations like what we have up here, because you've got 4 significant figures with this one showing precision and 3 significant figures in this one. So what do we do with this? Well, let's do a little more practice and then we'll come back to that one again. Now you know that these are non-zero, so there's 2 significant figures here, so I would underline both of them underneath the 3 and the 4. The next one, well, the 4 and the 3 again are significant, but what about this guy? He's actually a placeholder. He's not to the right of any decimal. He is to the right of digits, non-zero digits, but he's not to the right of non-zero digits. So when you look at that very last one, it helps you determine that, hey, this is not showing precision. This one is just a placekeeper. Okay, so go ahead and go through all of these and pause it. And I will have the answers there for you quickly. So go ahead and pause, and then when you're ready, click play, and then you can see the answers to these. If you have any questions on these, make sure you make a notation like a star next to it or something so we can talk about it in class specifically. Here are the answers. Okay. I want you to note that this one is showing precision, this one does not. This is to the right of non-zero digits and to the right of the decimal. That's that last rule again. This one, well, it's really the same as that guy up there. It's only got 2. This is just placeholder. Here's that special old-time rule that we know about. Okay. Notice that these ones are not significant because they are to the right of the decimal, but they are not to the right of any non-zero digits, so they are not significant. Okay, let's quiz yourself one more time with some other ones. Oh, wait, I forgot that I was going to do this too. So, anyway, which ones are with the last rule? Well, I was just talking about several of them with the last rule. All of these ones in here right now are all expressed with the last rule. Okay, does this one show precision by being to the right of any non-zero digits? Yes, but it's not also to the right of a decimal, so no, that one does not show precision. But all these do. So that last rule is important, and to understand the and portion of it. Now here are 6 more examples. I want you to go and underline them on your sheet, and for how many sig figs are in each one. And I'll put up the answers here real quickly, so pause. If there are any that you have questions about, please make sure that you make a notation next to it so we can discuss it in class tomorrow. Isn't this one amazing? It says 0.01 millimeters. That means that this one was estimated. So it was just a hair. It was a very, very thin measurement. Make sure that you recognize that these ones here, that's the estimated one. That is your significant one. That's important. Okay, moving on. Okay, so when we're calculating with sig figs, remember that old problem that we had? We recognized that the first one had 4 significant figures in it, the second one had 3 significant figures. So when you're multiplying or dividing again, you must choose the number with the least amount of significant figures. Okay, your answer can only have that number of them. So this answer can only have 3 sig figs. So we're going to start here. We got the 3, the 8, the 8. Now we need to figure out that we got to round up on that one. So we've got to round up. Okay, so we've got 3, 8, and a 9 that'll be rounded up here. Now that's not showing the value of the number, so we've got to still put that placekeeper there. So our answer can only have 3 sig figs, but guess what? This has only got 3 sig figs because this guy is not significant. So that's why it's important that we understand significant figures so that we can calculate, and so that we don't go and report something that a calculator hands out, because once you do that, you're lying and you're saying that your calculations and that your measurements are much more precise than what they are. We can also report this with scientific notation. You'll note that 3.89 has got 3 significant figures, and then we've got times a multiplier. So that shows how many significant figures that it is. And that's just another way of reporting our answer, so it shows the true precision of the instruments that we used. Now, scientific notation, let's go ahead and look at that. How many sig figs are in this one? Well, you could go and write it out if you want to, but there's really no need. You can just notice that this first part here has got 3 significant figures and this times a multiplier. So it's got just 3 sig figs. How many sig figs are in 3.000? Wow, these ones are showing precision because guess what? This is to the right of the decimal and to the right of any non-zero digits, same with these 3. So these 4 digits right here are all significant. So when you're showing with scientific notation, it kind of feels like that is too easy because however many are in front of that multiplier, that's how many are significant. So if you had to report 6 million and you could only have 2 sig figs, how would you write your answer? There's really no way to do this other than scientific notation. So you'd write 6.0 because this one again shows precision by being to the right of the decimal and to the right of any non-zero digits. So these 2 are significant, and then times your multiplier. Now, when you're adding or subtracting, you've got to do some things a little bit different. In fact, you've got to look at your values. This one goes to the nearest hundredth, nearest thousandth, nearest tenth. In fact, the nearest tenth is the one that shows the precision the best that you can do when you're adding or subtracting. So you've got to just pretty much kind of cut it in half there so that you're going to be not reporting any of these values over here. But I want you to notice something. These are still important to add on. So you can't cut it up before you go and add it because this number is a 5. That means that this one has to round up, right? So that is important so that you can report this to actually be 220.5 grams. You could have screwed up if you just cut these off before you added them on and didn't round up first. So make sure that you're aware of that. Now there is just one last way that we can represent our findings that's not just a numerical value, and that's by graphing them. Okay, and there are 2 types of graphs. I'm sure you recognize these from math over the years. Directly proportional and inversely proportional. Now, the first one that we're going to talk about is mass and volume. So we're actually showing a directly proportional one. A direct proportion means that as volume goes up, the mass goes up. So they both go up at some sort of rate. In this case, is the mass and volume of aluminum. So it's probably going to be about 2.7 for a slope on here because it's showing a relationship of its density. Okay, the slope is volume over mass, so that'd be density. Now, to be directly proportional, it also has to go through 0. There are lots of relationships that are, that look like that they're a direct proportion, but they don't go through 0. They're technically not a direct proportion. Now, again, as volume went up, mass went up. Now, the next one for an inversely proportional one, as the volume goes up, okay, what happens? The pressure goes down. So when the volume goes down in value, okay, the pressure is going up. So as one goes up, the other one goes down. That's called inverting. Okay, inversely proportional. So as one goes up, the other one goes down. And it's kind of like you got a negative slope for this one. And, well, it's a curve. It'll always be a curve. It might be very close to being a flat line, linear, but it's a curve. And so that's inversely proportional. Now, just to remind you, this one right here had a very linear relationship. Sometimes you'll plot your dots and they won't be on it perfect, so you'll just go and extrapolate one in there, and that's how you have to do that. So tomorrow we'll be talking about a couple of different formative assessments on significant figures or sig figs. They're also called significant digits too. That's an older term from back when I took the courses. So we'll be actually working on some of this work on significant figures in class with me. See you tomorrow.